Welcome to Let's Talk Micro. Hello, dear listeners. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, Goodpods, wherever you listen to podcasts, you can find Let's Talk Micro. As far as social media, I am on Instagram, TikTok, and YouTube as Let's Talk Micro, on X as Let's Talk Micro 1, on LinkedIn as Luis Plaza, and I have an email address which is letstalkmicro@outlook.com. So either via social media or via email, you can reach out with any topic suggestions, any feedback. They are always welcome and appreciated. So please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. Thank you so much for the support. And if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. Great resources from Dr. Timothy Gauthier, a very passionate pharmacist. So I want to take a few minutes to talk about the previous episodes as I always do. So last week it was the 4th of July on Thursday when the episodes, as you know, typically episodes premiere on Thursdays. So instead of a new episode, there was a throwback episode that was actually published in 2022, which was about respiratory cultures. And in this episode, Andrea Princey, which you know her from the AMR subseries that we do, she's the co-host. In that episode, she came in as a guest and she talked about respiratory cultures. So we really broke it down and we talked about pathogens, sources, types of cultures, oropharyngeal flora, and more. It was a great episode. And as you know, those cultures can be challenging in the lab. So that's why I decided to do an episode at that time. And it's great content. So it was posted again last Thursday. So if you haven't checked it out, please go ahead and do so. And then previous to that, there was a new episode about the microbiome where Dr. Crystal Eisenhower, she joined the podcast and we talked about the microbiome, more specifically so the human microbiome. And in the episode, she talked about the composition, what organisms we can see, we typically see based on the sites, what type of testing do we do for the microbiome, and then once we get those results, what do we do with them? And she also talks about applications of the microbiome. So all in all, it was a great episode, so definitely check it out if you haven't already. So today's episode is about body fluids, and we talk about body fluid cultures, and maybe those of you that work in the lab, sometimes you receive body fluids in blood culture bottles. And in this episode, it was about a study where those fluids that were placed in blood culture bottles, then once flagged positive, they were identified using the molecular systems that we use for blood cultures. Those of you that work in the lab, you're familiar with them. We have systems like the eplex, like the BioFire. In this case, identification was performed in the GenMark, the eplex. And in the episode, the two guests, they come in and they discuss the results. How did they do? So it was a great study, very interesting. And the applications of this, if this is something that could be done, it will definitely save some time. And by the time the plates, come from to the bench, you already have an ID, like the case is when you have blood cultures. One of the guests in the episode is Christina Cox. And the other guest is a returning guest that I had the pleasure of having him here on the podcast, who's Dr. Joel Mortensen, which was a guest on episodes 107 and 108 about a pediatric hospital in Guinea. He came into the podcast, he talked about setting up a lab over there. Great episodes, so if you haven't checked them out, please go ahead and do so. It was definitely a pleasure talking to Dr. Mortensen again and meeting Christina. So, all in all, a great episode. Let's go ahead and listen to it. So those of you that work on the bench in microbiology, you definitely might work with body fluid cultures, you work with blood cultures, and you might be familiar with, blood culture instruments and molecular tests that you do to identify blood cultures. So I came across this article and I was reading it about a study and I found it very interesting. And it is titled Clinical Utility of Multiplex PCR in the Detection of Pathogens from Sterile Body Fluids. This was published in March 12th of this year in the Journal of Clinical Microbiology from the ASM. So with me today, I have Joel Mortensen and Christina Cox. Christina and Joel, welcome to Let's Talk Micro.
Thank you for the invitation.
Yes, thank you.
My pleasure. So, for the audience, let's go ahead and start with a quick introduction, what you do, and anything else that you want to tell them.
So I'm Joel Mortensen. I direct the Diagnostic Infectious Diseases Testing Laboratories at Cincinnati Children's Hospital. And part of what I do is to think about how we apply all the kinds of technologies and stuff. So as we get into this more, this really was, I think, what I'm supposed to be doing on my job. I'm not sure everyone necessarily agrees with that, but there you go.
Hello, thank you, first of all, for having us here today. I'm really excited to do this podcast. For those of you listening in, my name is Christina Cox. I've been working as a medical technologist since 2017 in both the capacity of a microbiology bench technologist and a supervisor. For the past 4 years, I've taken on the very small role of becoming a PhD student. I am just now finishing up my thesis research on fracture-related infections. In fact, starting July 1st, I'm excited to say I will be applying to CPEP fellowship programs. So if there are any program directors listening in, I will be in the market for a position. But getting back to why you brought me on the podcast today, I'm really excited to discuss the method we evaluated in an effort to improve diagnostic testing for pathogens present in normally sterile body fluids.
Very subtle, Christine. Very subtle. I love that.
Thank
You're
you.
welcome.
Had to throw that in there.
Well, welcome again. So, let's go ahead and talk about the study. What was the purpose of this study?
So, Louis, again, I very much appreciate this, and this was an interesting study because since the 1980s and 90s, we've been looking at body fluids that you can stick in blood culture bottles, really as a way to get better sensitivity, but also to have less time dealing with manual cultures if we can let an automated blood culture system do it. And Paul Bourbeau, years ago, decades ago now, actually pioneered some of that work of putting other fluids in. And we also did some work at Cincinnati Children's looking at spinal fluid to see if we could put spinal fluid in blood culture bottles, and found that actually it was terribly difficult because you needed to supplement them. So we used guinea pig blood and horse blood and leftover human blood and bat wing and eye of newt and other magical factors, none of which worked out very well. So we sort of gave up on spinal fluid, but lots and lots of other things have enough nutrients to support the growth of the organisms that we're interested in. It was also about that time that people started doing platelet sterility in blood culture bottles as well. So we call them blood culture bottles, but they're obviously really not. They're for all kinds of things. So we got one of the newer blood culture systems at Cincinnati Children's and simply applied what we were doing. And the Virtuo system, or the bioMiraU as an overall platform, is FDA cleared for doing fluids other than blood cultures in those bottles. So I was interested in what people were doing, and I did a quick survey of other laboratory directors and found that really all kinds of different fluids were being done by different people, from a few kinds to everything that they could stick in a bottle. Often there were routine cultures done in parallel. One thing that people are not doing is lumbar punctures in general, because as we found out, they don't work very well. And most of these are inoculated in the laboratory. So we looked at all of that and said, maybe there's an opportunity here to do two things: encourage laboratories, and certainly our clinicians here, to put fluids in bottles that are normally sterile fluids. We only expect one organism when appropriate. And that lets the laboratory have, we think, better sensitivity, but a lot less hands-on time. And then we began to think, well, could we apply some new modern technology? In our case, we had just moved to the GenMark system, to the eplex system. Can we apply any of that to, again, further look at sensitivity and workload, but the additional factor of turnaround time? Can we get them done and get them out the door? So we did an initial look, and we found that we did about 2,000 samples from peritoneal dialysate, joint and synovial fluid, pericardial, peritoneal, and shunt fluids. And of those 2,000, only about 3% of them were positive. So we had a lot of plates and a lot of thios and a lot of bench technologist time spent looking at a bunch of negatives. So couldn't we streamline all of that, add some molecular in, and really make an improvement in the laboratory? And so that's where the idea came from, was what can we do with the technology that we have today?
Well, thank you for that. And just for the audience that are listening to the first time, definitely Dr. Mortensen was a guest before in the podcast. So if you want to check out some previous episodes about a laboratory that he helped implement in Guinea, fascinating stories. So I definitely invite you to check them out if you haven't. And just to go back to what Christina said, they do actually listen to it. I have the fortune to meet a lot of directors, and lately I've been meeting a lot of CPEP fellows and great people that they're listeners. So yeah, just putting it out there too. Um, yeah,
Nice.
yeah. When it comes to and you already answered some of the questions. I can definitely identify with, definitely as someone that works on the bench reading cultures. You do get a lot of negatives, and you do have a lot of plates, and it's a lot of work you're sifting through. A lot of the work is spent when you're doing those particular cultures, looking at negatives. I wanted to ask something, and this is something that, as the article mentions about, there are some limitations of routine body fluid cultures, and I was just wondering if you could expand on that a little bit.
Sure. Let me kick that off, and then I'll let Christina jump in. I think the obvious one that I mentioned already is some fluids don't grow in bottles inherently on their own, and we have to be aware of that. So again, lumbar puncture spinal fluids we don't put in bottles. We did a lot of work here at Cincinnati Children's, not in this particular study, but looking at what other fluids could be supported in, and most all of them do really, really well. In fact, because because the shunts, the ventricular shunts, have usually a lot of fluid, they have a lot of nutrients, they actually work really well in bottles, and we're looking at moving in that direction. There are some pragmatic things about who inoculates, and do they do it at the bedside? Do they bring it to the laboratory? There's some of those kinds of limitations. And anything that's going to be mixed. So the last thing you want is 3 or 4 organisms squirted into a bottle, and then they're all competing and making a mess, because then you have to subculture the bottle and essentially start all over again. So I think there's a number of things to keep in mind. But I was surprised at the number of normally sterile body fluids. Peritoneal dialysis, for example, is one of ours, that we have a lot of those that we spend a good deal of time on, that now they inoculate it at the bedside. We don't have a delay in inoculation. We let them go. But we just need to keep in mind those other limitations.
And I'll also jump in here. So at University of Cincinnati, we do have body fluid cultures that are brought to the lab in bottles. If they're not brought in bottles, we inoculate them to the thioglycolate medias. And the bottles are just so convenient here because you have to read the thioglycolate medias, every day. And with the blood culture bottles, they're just automatically looked at through the instrument. So reading thios isn't standardized throughout the laboratory community. So if the body fluid is just put in bottles, it's very easily, routinely looked at by the instrument. And not to mention the variability that I think Dr. Mortensen mentioned in determining whether a thioglycolate media is positive, and also the potential for false positives or contamination rates.
Definitely, and yeah, and with an instrument like like let's say like the virtual, where you typically, you only load the bottle, and then once it's negative, that type of system where you just, it stays there, and if it's positive, it flags, and then the negatives, they just automatically discard. Yeah, one of the things, and it just came to mind, and we'll definitely talk about the results, and it's just pop into my mind when you're doing like this type of system. Like sometimes, when I'm reading blood cultures, right, and you do the initial ID on the system, and sometimes, you see 2 or 3 things detected, and people go ahead and report that. It always makes me a little iffy, right, until you actually see it on the plate, because there are some limitations to the system, which sometimes you see, oh, serratia detected, and then, well, there's no serratia growing, or things like that, for example. It's something that came to mind. Okay, and as you mentioned, so that is something actually, and the article did say, and you touched on that it's this is something that's routinely done at your institution, that you plate body fluid cultures in bottles. So let's go ahead and if you can just talk more about the study and expand a little bit on that, some of the findings and procedure results?
Absolutely, and I think this is a perfect time to tell the truth, which is the idea generated. We generated the idea sort of over coffee and on a napkin and sitting around, and then I got to write the grant to get the money to support the study, which I really enjoy doing. And then my goal was to find someone who actually wanted to do all the immense amount of work that was really involved in doing the study. And so Christina said, "I'd love to do it." And I said, "I'd love you to do it." So for in full disclosure, I got to do the great easy part up front and then hand off all the data collection, because you got to remember, we're talking two different major institutions. Now we're right across the street and we play well together and we all know each other, but two major institutions keeping track of all the details of this entire study. And from design, Christina was involved from design all the way down, but really key is she actually made the study happen. So I'm going to just let Christina talk about sort of the components of the study, and I'll chime in, but really this is her part of the piece where she really did the work.
And I'm really excited that, Dr. Mortensen can talk about all the fun stuff and then hand over all the boring stuff to me. So, but to me, it is not the boring stuff. It's actually the really exciting part of actually doing the study, making it work, and working between the two institutions, which not many people, they don't get the opportunity to do that every day. So I'll just to get started with talking about this. And if you have any questions throughout the way, feel free to throw them out there. For the study, we started with 88 samples. So these were all body fluid samples. We collaborated between these two institutions, which was really essential because UC has adult patients and Children's has pediatric patients. So we took 50 samples from UC and 38 pediatric remnant samples from Children's. University of Cincinnati has aerobic and anaerobic bottles, and Children's, for the most part, uses pediatric bottles. All these bottles were processed in the laboratory and put on an automated blood culture instrument. So these are left on the instrument for 5 days. Synovial fluids are usually left on for 14 days. And we used the Children's used the Virtuo, and UC used the Bactialert 3D. So when these bottles flagged as positive by the instrument, the standard process in the clinical lab was followed, which consists of gram stain, culturing, and reporting the critical results. We took each of these samples and aliquoted them to be frozen at -80 degrees Celsius. And once we were ready to test, we took out the aliquot and let them come to room temperature before testing. We put it on a panel depending on the gram stain result. For eplex, they have the gram-positive panel, gram-negative panel, and fungal panel. When we were doing this testing, we were able to test 20 peritoneal fluids, 20 CSFs, cerebral spinal fluids, 26 pleural fluids, 14 synovial fluids, 6 peritoneal dialysates, 1 pericardial fluid, and 1 abdominal drainage.
So maybe we need to step back for just a quick second. And I think that was a great summary, but maybe everyone might not be familiar with the GenMark system and what we're doing. So what Christina was describing is that the study was not designed to look at, does a peritoneal fluid grow well in a blood culture bottle? But the study was designed to say, if you put it in there and it grows well, what do you do with it then? So we were talking about putting different kinds of specimens in blood culture bottles. And that is absolutely what we do, and we do it routinely. But the real innovation here was putting the positive bottles into the GenMark system, which, for those of you who may not be familiar, is a molecular system that has multiple PCR primer sets for common gram-positive organisms from blood cultures, common gram-positive, gram-negative, and then a fungal panel. So in total, there's about 60-some target sets along with some resistance markers. So it's similar to the BioFire and to the Verigene in its molecular detection and of both organisms and resistance markers. So we take an aliquot, you pop it into the cartridge after you've done your gram stain, positive into positive, negative into negative. Because people have asked us, well, can you use the BioFire to do the same thing? Does it have to be the GenMark eplex? And I don't think it does. I mean, we didn't do the study, but once you have nice positive growth, I don't see any reason that other systems won't give you the same amplification, detection, and reporting of key gram positives, gram negatives, fungals, and some resistance markers.
Thank you. I almost forgot that part.
Thank you for that.
As Dr. Mortensen was saying, we were able to put these sterile body fluids on the eplex systems. Once we had the results back, it takes about an hour and a half to run. We compared each target detected to what was isolated on the culture side in the clinical lab. So we were really happy with these results. We had around 108 analytes detected between the two methods. Only 8 samples had discrepancies between the methods, giving us a total agreement of 91%. And when performing these calculations, as you could see if you read the manuscript, we divided the samples between monomicrobial and polymicrobial samples just to make it easier to read and easier for the results to be deciphered. So 78 out of 88 samples were monomicrobial in culture. 4 of these samples grew organisms in culture that didn't have primers available on the panel. These organisms included Acinetobacter loafi, radioresistans, a Pasteurella species, and a Corynebacterium pseudogenitalium. When excluding these organisms, the percent positive agreement was around 98 for gram-positive organisms, 92 for gram-negatives, and 100% for yeast. The negative predictive value was 100% for all of these samples. We did have 2 discrepant samples for the monomicrobial cultures, and this was a Micrococcus species and a Pseudomonas aeruginosa that was detected in culture but not picked up by eplex. The 10 remaining samples were all polymicrobial. 8 of these matched completely between culture and multiplex. One of the 2 mismatched samples had Staphylococcus epidermidis and Staphylococcus aureus detected in culture. Eplex only detected the Staph epi. The second discrepant sample was an abdominal fluid. This had multiple organisms isolated through eplex and culture. There was a Candida glabrata and also an Enterococcus faecalis seen in both eplex and culture for the sample. Eplex also detected a Corynebacterium species, an Enterococcus faecium, and a Lactobacillus that weren't seen in culture. And Staph epi was only isolated in that culture and was not detected by eplex. So when we compared results between these all the fluids, pericardial, cerebral spinal fluid, peritoneal dialysate fluids all had 100% positive predictive value. Peritoneal pleural fluid and synovial fluids had 97, 98, and 96% positive agreement, respectively. The abdominal fluid did have the lowest percent agreement of 60%. However, there was only 1 sample included for this category. And so I'll just stop with the results in case you all have any questions before we get into the conclusions.
So I will say that as we were designing the study, it's a little bit complicated with polymicrobials, and we're comparing culture to a molecular methodology. We expected the molecular to detect a few more organisms than the culture did. So although we were thrilled, I was thrilled with the positive percent agreements and negative percent agreements. We expected to have a few slight differences. And I think one of the questions is how do we adapt to those differences in a laboratory setting? What are the real advantages and the disadvantages?
Well, thank you for that, Christina. And just for the listeners, I know earlier on when I was starting the podcast, I did talk about the systems, and definitely, if you're in microbiology, more than likely nowadays, pretty much all the labs have one system or the other. I really like the eplex. I have worked with the 3 different ones that are used there. I mean, this one definitely, it's easier. When I got my start, I was using the nanosphere, the Virgin system, and with all those components, that was a little bit of a nightmare. So definitely the eplex is easier when it comes to that, and I have touched on them at some point in the podcast. So definitely for the audience, if you wanna check them out. But yeah, as you were talking about some of the results, and then Dr. Mortensen mentioned, right? So the systems, they come with some targets. So of course, you're not gonna get all the organisms that grow on a plate detected on the system. That's just typically in the, and this is just a little bit for the audience, and bear with me. A lot of the systems, you typically have like, Staph aureus, you get like strep A, E. coli, Acinetobacter, Pseudomonas aeruginosa, and a lot of other organisms. But when you get more specific than that, then it's just not going to be part of that panel, and some resistant mechanisms. So before we jump into conclusions, right? So definitely there's a limitation when it comes to that from the instrument, that it doesn't have the targets. But with any study, right, we always have some things that work well and some don't. There are always other limitations. So maybe do you have any of those? And if so, can you talk about those?
For me, I do think the biggest limitation is there are a few samples that don't have organisms that are available on the eplex. But when looking at a lot of the multiplex panels that are developed, there are usually gaps in organism identifications just of how the panels are put together. And for that reason, in the manuscript, we did recommend that the panel can be used as a supplement rather than a replacement for culture, because you would still be culturing side by side with getting eplex results, and then the next day you'll have your culture results that you can compare it to.
Yeah, and just to build on that, I think it is clearly a limitation, and I agree. I think everyone should be doing culture because you also need an organism to do susceptibility testing. You want to make sure it's not mixed. And honestly, it worries me in microbiology if all you have is this molecular result. I guess maybe I'm just old school and want to make sure that my Staph aureus looks like a Staph aureus and there aren't some, micrococcus hanging out or an Acinetobacter trying to masquerade in the background. So I strongly support the idea that we can use the advantage of the turnaround time. We can use the advantage of the molecular markers for resistance, and yet marry that to conventional culture to still retain the ability to confirm identifications if we want to, and to have the organism that's isolated so we can do susceptibilities for whatever we need to after that.
And I do think that brings up a really good point of that. Although technology is advancing and it's becoming so much more prevalent in the microbiology lab, the trained human eye and the medical technologists that work in the lab are so important to recognize what a colony looks like to match it to a multiplex ID that they would have had the day before.
No, definitely. And I'm not old school. I mean, I like to think that I came out a good time in the lab. I do agree with what both of you are saying. I mean, I came in right before Multiplex, so I got some years of, we have Vitec, but I still got to do a little bit of the older tests and then incorporate that with the new. But yeah, definitely, as MLS, working on the bench, we need to, yeah, we are trained and we recognize, and it's very important that even when we have systems like this, now that we've seen, like, for example, like direct susceptibilities from blood cultures. I mean, when we can perform them, but then we still, like in our case, and then we play it and then we look at the organism. Okay, this is what's growing. This is what it was ID. This pattern, matches with what we're seeing on the plate, and then we release that result. But it will definitely make me a little, yeah, uncomfortable just not doing the actual culture. It's just, yeah, no. So anything other than, so you touched on the conclusions. Is there anything else as far as that? So it's definitely to be used, right, in helping in alongside the culture. Is there anything else?
I think I just want to say that, this panel did maybe overgeneralizing a bit, but it did a great job at detecting the organisms before they would have been seen in culture. We do have numerous positive cultures in the lab that are only positive by the thioglycolate media or the blood culture bottles, and this would have given us the ID at the same time the nutrient broth was positive. So rather than calling the doctor with just the gram stain result in the thioglycolate media, we have the potential to give them an organism identification in the same day. And now, we could potentially apply this to various instruments that are seen across institutions, making it much more accessible rather than adding another instrument to the laboratory.
And I wanted to go back and sort of where I started with this, because what I want to do is encourage our clinicians and our laboratories to utilize things like the blood culture bottles and the automated detection whenever appropriate. And it's sometimes a little difficult to figure out when appropriate, but for example, we're moving forward with those ventricle and the shunts from ventricles in an effort to compensate, if you will, or help support literally hundreds of shunt cultures that we have here at Cincinnati Children's, and the technologist spending lots and lots of time looking at thios. And because of the organisms, we have a 14-day protocol. So for 14 days, they're looking through racks and racks of thios that I think this is going to really streamline that. And I think this is a nice example of simply applying the technology, perhaps a little beyond the FDA clearance or the approval, but really stopping to think about what can we do with this that will give us better patient results, that'll give my technologists time to focus on things that they need to focus on. Because I think technologists, unfortunately, are still stuck with some kind of routine things where at the same time I've got amazingly complex cultures that require careful thought process, that are not just looking at every tube in a rack to make sure that the thio is still negative. I'll also tell you that we're going to take all of our fluids, and I don't know what UC is doing, but we're going to take all of our fluids in blood culture bottles and put them at a standard 14 days. Because I think we're going to pick up a few more positives that are stragglers that we would not have gotten on a routine blood and chocolate or even with a thio. I think some of these are unusual enough specimens that we'll be able to find some other interesting things and really not take any more effort. We just let the machine do what the machine wants to do.
And at UC, I'm not always part of those discussions. So as of right now, we are holding them in the instrument for 5 days, other than synovial fluids, of course, that get held for 14 days. But that would be interesting to look at in the future for us as well.
Yeah, I mean, I have to say, like this instruments, especially the virtual, it really it's very sensitive. And I remember when we switched, we used to have the 3D. So you have to like open the drawer and then scan all your bottles, and sometimes, because of the time that those drawers were open, you will get a lot of false positives. They will flag, and then you will have to set it up. And I talked about the audience, about the process. So, but yeah, like we started seeing some like at sometimes 4 hours, popping positive, and then initially you wouldn't see anything, and then you would do a cytospin, and you would see organisms. So that was just something very. I was very impressed when we started using that one. And yes, as Dr. Mortensen said, when that's the part of the bench that I don't like, when you're sifting through those thios. And yeah, I love reading in place, and you put me, but yeah, definitely.
Gram staining.
Yeah, it's very time consuming, definitely, and you do have some of those cultures, like he said, that sometimes you have many organisms, and then you have to make some sort of determination. So there can be time consuming. Something's not working right. So those, I think that sometimes with things like this, we can focus our time devoted to things that are very time consuming and very important. Is there anything else that either one of you want to add?
Yes, I do want to say one of the limitations of our study was not looking at the cost analysis and the resistance markers. Just because of the sample size and what we were doing between the two institutions, it was hard to standardize. So I do think that's one really important thing to look at in the future when implementing this method.
And I've certainly gotten questions about, well, the study didn't really have enough specimens. You're right. This was our first shot, and I would love to have some other people replicate this and add some power to the ability to make this kind of determination. So, I encourage anyone who has the opportunity. But based on that, I have to tell you that one of the reasons that we did this study was everybody can't do this kind of study, right? And so we were unique in the ability to have 100 samples or so, to be able to have the support from Roche to do the study. And I consider that part of the role of us academic institutions, is to help support people. So although we didn't have as many specimens as we would potentially like, I think it's a nice lead in, and especially for people who are saying, well, gosh, I'd like to try that, but I can't really do 100 specimens and have this big study. So I think that's one of our roles. I think the other thing I wanted to do is thank Christina for all the hard work that she put in, and it really made the study possible, is to get that amount of effort in spreadsheets and running back and forth with specimens and stuff. So thank you very much. I want to make sure we acknowledge GenMark and Roche for their financial support, and lots and lots of cartridges and many phone calls, and a lot of effort put in by GenMark to help support us. And at least on my side, I want to make sure I acknowledge Katie Ruger. She's our technical specialist here in microbiology at Cincinnati Children's. And without Katie, I wouldn't be able to do much of anything, let alone these kinds of studies.
And I also want to say it was absolutely amazing to work with such a passionate and seasoned, because Dr. Mortensen won't let me call him old, group of individuals. And Dr. Powers, my PhD advisor and longtime mentor, really helped with this project, as well as Dr. Powell, one of my committee members and mentor. And last but not least, of course, Dr. Mortensen, who let me run with this opportunity. And I think all the folks in the clinical lab at both of our institutions deserve a shout out for all their help and acceptance of me taking over their space often. So thank you.
Yes, and I didn't mention Ellie Powell, and I certainly should have, because we tortured her pretty much on this project as well. And Louis, thank you also for giving us this opportunity to share. I actually get, after the last podcast you let me do, I got a number of people reaching out, and so it's obvious that the community listens and is interested in what you have to present. So thank you again for this opportunity.
Definitely a pleasure, and it was a treat. I mean, I definitely enjoyed having you the last time, and then when I was reading this article and I saw your name in it, I'm like, okay, this is gonna be great. And definitely, Christina, thank you so much for accepting my invitation as well, and taking some time to be in Let's Talk Micro. So thank you both.
Thank you.
My pleasure. And that, my dear audience, is the end of this episode. I hope you enjoy listening to the study about blood culture bottles and body fluids and identification systems, in this case the GenMark. As always, I enjoy sharing this information with you. So please continue bringing that passion to what you do. It's so important. You do such great work. And hey, I hope you're having a great summer. If you're vacationing or taking some time off, have a great time. It's always good to stop and recharge your batteries. So, stay tuned. Great things coming your way. I'm always working on bringing great content. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.